Assalamualaikum and hi. My name is Nur Safia binti Muhammad Faizal, and today I will present about our FYP project, which is production of pectin-based biofilm from vegetable waste. Let's start with introduction first. So for the introduction, the rapid increase in Malaysia's population has led to significant rise in water production, particularly plastic waste. However, by recycling these resources into bioplastics, homeowners can effectively reduce their waste output. One major issue is the improper disposal of vegetable waste and widespread use of petroleum plastics, posing health risks and environmental degradation. Bioplastics made from organic materials offer a sustainable alternative as they degrade faster than traditional plastics. They can be used for various purposes such as trays, containers and packaging, reduce waste while enhancing development. Additionally, bioplastics can break down into methane and carbon dioxide, and they can be recycled into new products, contributing to waste reduction efforts. Overall, the promotion of bioplastics aims to replace petroleum-based plastics in daily life, reducing society solid waste disposal. That's all for introduction. So for the problem statement, we have three problem statements, which is first is the manufacture of plastic release gases that worsen climate change by Shen 2018. Second one is the widespread use of conventional plastics has led to environmental degradation and waste accumulation by Ali 2020. And the last one is research on the benefits of pectin has not been widely studied by Yadav 2008. So that's all from me.
Hi everyone, my name is Amira Farnas and I'm going to explain to you guys about the methodology. So our first intention was to compare the extracted crude pectin biofilm with the pure pectin biofilm, but we're facing a few problems, which is one of the problem is insufficient amount of extracted crude pectin. So after a few discussion, we decided to modify the sample into three groups, which is the combination of the extracted crude pectin with the vegetable powder, and then two non-combination, which is extracted crude pectin and vegetable powder. So the method to do the fabrication, we follow the journal from Peru to 2018 and 2020, and then basically we have four tests, which is visual observation, tensile strength test, water absorption, and also the soil biodegradability. So the first test is a visual observation. 7 out of 14 samples were successfully undergo fabrication of the biofilm. So the picture that I put here are the example of the sample that we do. So the next one is tensile strength test. So the objective of the tensile strength test is to determine the maximum force that sample can be held. So basically, we cut the sample into the dodgeball shape, and then from the result, we can obtain that the combination sample can help into 12 MPa of the force. Next is water absorption test. So basically, the objective of this test is to determine the ability of the sample to absorb or retain the water. So this picture show how it looks like during the test. So from the result, the negative value obtained indicate a net loss weight due to drainage of the soluble component in the bioplastic along with water. So basically, all the sample was dissolved in the water. So the last test that we did is soil biodegradability test. So the objective of this test is to test the ability of the sample to degrade in the soil. So the duration of this test is 1 week, and we record the data once every 2 days. So also the soil will be slightly moistened each time the data is recorded. So basically from the result, we can obtain that the non-combination sample can successfully degrade in the soil.
Hi, I'm Sharifah Najwa. I will be a third presenter. I will continue about the commercialization and also the impact of the bioplastic. So there are two products that we can be made. So for example is in the packaging. So one of the criteria that bioplastic can be made is the it can be degraded, which means it is biodegradability. So the biodegradability is a feature often soak when it comes to the food packaging for perishables. So the performance. So when it comes in the protecting the food or prolong the shelf life, so the performance of bioplastic packaging is comparable to that of exacting the conventional packaging, and sometimes it can be better. So second, in the agriculture and horticulture um, product, which is films for banana bushes and also mulching films. So this product is most important in organic farming and also vegetable growing because it can be minimum use of pesticide in the farming. And next, biodegradable plastic also can offer opportunities for both plant marketing. Herbs are good for the examples. So once the are harvested, everything, including the film, can be composed. So alternatively, the product can simply be planted into their pot, which is very convenient for hobby gardener. And also the advantages of agriculture plastic are also clearly acknowledged by the United Nations Food and Agriculture Organizations. Next is the impact for production of biofilm. So firstly, it can reduce the waste on earth. So our project use a lot of waste from food and fruit and vegetables. So indirectly, it also can reduce the waste on the land. Secondly, it also can reduce the greenhouse gas emission because bioplastic produce significantly fewer greenhouse gases than conventional plastic over their lifespan. So less energy is required to produce the bioplastic, and less carbon is produced when bioplastic waste is processed, especially when compared to generic mixed plastic waste. Lastly, it also can enhance the biodegradability because bioplastic will biodegrade naturally over time under the right condition compared to the plastic. So bioplastic will naturally decompose in 3 to 6 months, but plastic can may take around 450 years to disintegrate. So that's all from us for production of biofilm, and thank you for watching.